Hey everybody, and welcome to another physics lesson. In this video, we're going to start electrostatics. Electrostatics is a study of electric charges that can be collected and held in one place. We have witnessed objects that are electrically charged before, such as a balloon when it sticks to a wall, or when we use a comb where it attracts the strands of our hair. But what is causing it? It might be helpful to know that charges can be positive, negative, or neutral, and they interact with each other in specific ways. If the charges are alike, they will repel, but if the charges are opposite, they will attract. How could an object become charged? If we recall back to subatomic particles where you remember the proton, neutron, and electron, you might remember that electrons are capable of leaving or entering orbit. This could cause the object to be positive or negative based on excess or missing electrons. Remember, though electrons can leave or enter, protons cannot, as it would change the identity of an element. If an object is charged, it can exert a push or pull on other charged objects, which leads us to electric force. Electric force is defined by two charged objects near one another may experience acceleration either toward or away from each other because each object exerts a force on the other object. Coulomb's law allows us to calculate the electric force based on the amount of charge and how far or close the charges are to each other. The equation for Coulomb's law is electric force equals to Coulomb's constant times the absolute of charge 1 and charge 2 divided by the distance squared. Coulomb's constant is 8.99 times 10 to the 9th Newton meter squared per Coulomb squared. You might notice that Coulomb's law has some similarities to Newton's law of gravitation. Let's do a short example. The electron and proton of a hydrogen atom are separated on average by a distance of 5.3 times 10 to the negative 11 meters. Find the magnitude of the electric force. We're given the charges of the electron and proton and know how far apart they are. Using Coulomb's law, the electric force can be found by plugging the values in. With that, the electric force is 8.2 times 10 to the negative 8 newtons. Let's move on to a more complicated example. Consider 3-point charges in a right triangle formation. The first charge is 6.0 times 10 to the negative 9 coulombs. The second charge is negative 2.0 times 10 to the negative 9 coulombs. And the third charge is 5.0 times 10 to the negative 9 coulombs. Find the resultant force on the third charge. Two charges affect charge 3 in some way. Charge 2 and charge 3 are opposite, and they will be attractive. While I can draw two vectors pointing toward each other to indicate the attraction, the problem asks how the third charge is affected. To avoid a possible confusing diagram, I'll only keep the vector off of the third charge. We can go ahead and calculate the electric force of each pair of charges. Let's start with the pairing of charge 2 and charge 3. Doing so gives an electric force of 6.0 times 10 to the negative 9 newtons left. The reason the direction is left is because this charge 3 is being attracted to charge 2, so it's experiencing a pull to the left. Charge 1 and charge 3 also affect each other in a repulsive manner since they are both positive charges. A vector will be drawn up and to the right off of the third charge to show how charge 3 responds to charge 1. Next, we can calculate electric force between charges 1 and 3, and this gives us an electric force of 1.1 times 10 to the negative 9 newtons. This answer points in two directions, up and to the right, and we'll have to break it into its x and y components. We'll need the angle to do this, but how do we find the angle? We can refer to the right triangle formation to find the angle. Remember, through geometry laws, these two angles are equal. I preferably will always use the angle between the diagonal and horizontal side of the triangle. Using the tangent function, I can find the angle to be 36.86 degrees. Now with the angle, I can break up the electric force of 1 and 3 into its x and y components. This gives us a x component of 9 times 10 to the negative 9 newtons to the right, and a y component of 7 times 10 to the negative 9 newtons up. I'll have to combine the x component force with the electric force between 2 and 3, as they are opposite forces. Doing so will give me the total x electric force. I don't need to find the total y electric force because there is only one force in the y direction, and therefore it has to be the total. Taking the total electric x force and the total electric y force, we use Pythagorean theorem to find the resultant force. Lastly, our answer is not complete without a direction. The angle can be found by using the tan inverse of the total y force divided by the total x force. This gives us an angle of 66.8 degrees. The complete answer is 8.0 times 10 to the negative 9 at 66.8 degrees. You can use a couple ways for the answer. You can express the angle north of east, or you can say above the horizontal. Alright, so this problem was rather lengthy, but I hope you found this video helpful, and thank you for watching.